For close to 20 years, there was a desire for the construction of a multi-use pedestrian facility along the frontage of Lake Monroe. How best do you approach a complete street redesign of a corridor which is known for high traffic volumes, high vehicular speeds, restrictive right-of-way, and historically prone to hurricane damage? This is what CPH was challenged with when beginning the US 1792 RiverWalk Phase 3 project for the city of Sanford. Our engineers began by evaluating the existing paved surfaces, drainage systems, and existing seawall for integrity and resiliency. For example, the existing 60-plus-year-old seawall was failing primarily due to being overtopped by ever-increasing lake levels. With steep slopes above the wall, washouts would expose the existing anchorage system. Could higher walls be a viable solution? CPH worked with jurisdictional agencies to use existing allowances for seawall replacement to facilitate the construction of a new seawall immediately adjacent to the existing seawall, eliminating time-consuming and expensive sovereign submerged land impacts. The overall height of the seawall was raised to accommodate fully ADA-compliant areas from the edge of roadway to the top of wall, a 5-foot height increase in some areas. The increased height ensured that current maximum stage lake levels would not exceed the wall height. The increased wall heights in combination with a unified seawall cap and beam allowed for the existing seawall to remain in place. The new helical pile anchors could be placed over the old wall top, eliminating unnecessary removal of the previous seawall cap or structure. The use of helical anchors in this capacity provided for direct load testing during installation, effectively allowing every anchor installed to be tested based upon measured resistance and depth of the installation. The goal was to create a pedestrian and multimodal focused corridor utilizing complete street principles. A challenge we faced was how would it be possible to also accommodate these parallel facilities. The major intersections utilized extended center and auxiliary turn lanes to accommodate the high design speeds. We considered what if the speeds were reduced or if the turn lanes were no longer required. The introduction of mini roundabouts within the tightest portion of the corridor allowed for the elimination of extensive turn lanes while also introducing natural traffic calming through the reduction of vehicle speeds. The roundabouts were supplemented with strategic separator islands for the larger, undeveloped areas of the project, and with continuous median separator islands for the developed areas. Strategic use of raised speed tables furthered the traffic calming with allowance of cautionary transition speeds of 20 miles per hour. We replaced a dangerous non-stop controlled crossover intersection with a full roundabout, providing a unique bookend feature, significantly increasing safety. Through utilization of complete street design principles, vehicular speeds were significantly reduced, facilitating a safe and resilient multimodal corridor.